This is the Excel example of confidence interval and hypothesis testing for two populations. The parameter being two population proportions. So here is the data, and this data is about call center operations, the time taken to answer a call in seconds. So we have two call centers, one in Mumbai and another in Manila, and randomly selected phone calls and how long did it take for an operator to answer the calls. So here the problem is for call center operations, one of the most important performance measures is what proportion of calls are answered within 20 seconds. So that's what we are interested in, testing whether there is a difference between Mumbai call center and Manila call center. In this case, S is defined as call is answered within 20 seconds. 20 seconds or less. Okay. It doesn't take more than 20 seconds. So P sub 1 is the proportion of S calls in Mumbai. So P sub 2 then is the proportion of S calls for Manila. So N sub 1 is the sample size or number of calls in the Mumbai sample. And N sub 2 is the same for Manila. So we have two samples, one from Mumbai and one from Manila. So P bar sub 1 is the sample proportion of S calls for Mumbai. Okay. And therefore P bar sub 2 is the sample proportion for Manila. So what is the hypothesis? We want to check to see whether there is a difference. Okay, the example is there sample evidence to conclude that the proportion of calls answered within 20 seconds is different for the two call centers? So that means we want to test whether P sub 1 is not equal to P sub 2. So P sub 1 minus P sub 2 is not equal to 0 is the alternative hypothesis. So is it equal to 0 is the null hypothesis. Okay, now we have to set up the sample summary data. So let's give a name to these two columns of data. Since the number of calls are different for the two different call centers, we have to do this individually. So that's your Mumbai column, and here is the Manila column. So we can say sample size is now count Mumbai. Okay, the number of S calls is count if. We want to count the Mumbai calls, and we want to see whether it is less than or equal to 20 seconds and count only those calls. And same for Manila. So count of Manila is the sample size, and count if Manila less than or equal to 20 seconds within quotation marks. So that will give us the number of S calls. So point estimate is number of S calls divided by the sample size. That's our P sub 1. Let's put one more decimal place there. And that's our P bar sub 1 and P bar sub 2. Now we want the pooled estimate for hypothesis testing. So pooled estimate is you can sum the two S calls divided by the sum of the sample sizes. That is another way of computing the pooled estimate. Okay, once we have the pooled estimate, then we can compute the standard error. The standard error formula is square root of P times 1 minus P bar times 1 minus P bar times 1 over n sub 1 plus 1 over n sub 2, and that is the pooled, that is the standard error based on pooled p-value. And here is that formula. This is the formula we used right here. Next is zcalc. So here is the formula for zcalc. So it's the difference between P bar sub 1 and P bar sub 2. So here is P bar sub 1 minus P bar sub 2. You divide by the standard error, which we have just computed, which is that. So that gives us the calculated z statistic value, and then we have to compute the p-value. P-value, we need how many tails there are in this sample, in the hypothesis, and this is a two-tailed test. So the p-value formula for two-tailed test is, here is the two-tailed test formula, 2 times 1 minus the norm dist formula. So here is that formula. So p-value is 2 times 1 minus norm dot s dot dist, then absolute value of the z statistic, comma 1. So this will give us the p-value. Okay. And the conclusion is, since the p-value is greater than 5%, do not reject H sub O. So now we have to interpret it, and two parts to it. First, the decision. So we do not have sufficient evidence, sufficient sample evidence, sufficient sample evidence to conclude that the proportion of calls answered within 20 seconds is the same for the Mumbai and Manila call centers. So that's the first part. The second part is the interpretation of a p-value. So now since we did not reject HO, we have to now say that if we rejected, in other words, if we concluded that these proportions are not the same, then the probability that the conclusion is wrong is 5.5%. Now justify the text, and that's the hypothesis test for two population proportions.